Agostino Calamia, co-founder and CTO of LaunchLab, specializes in contextual AI and data-driven product development. With experience in leading tech companies, he creates solutions that make AI more human and more useful. His vision shows where the next generation of intelligent systems is heading.
The title is pretty long, even though it doesn't need to be that long anymore. So I'm going to talk about autonomous systems with reproducible outcomes. So that basically just means, how can you use an AI that actually does continuously what you expect it to do? And that's basically what we go through. So first of all, why it matters, why it's so important, how people are currently evaluating how their AI systems are working. Then we propose a 4-step solution to build a judge, so something that judges your system to make sure it actually works, how an autonomous system could look like, and common pitfalls that you should avoid if you use AI or build systems or designs. That's me with a very different haircut. I've been in ML and AI for a couple of years. I used to work in fintech and retail before, so very different industries, was both fun, but this year I decided to found my own company where we build AI agents for smaller founding teams where we help them to grow a little bit. Enough of that. Why it matters. So why is it so important? We heard it today multiple times already. People really emphasize that you should keep an eye on how you use AI and what you do with it. And there are a few reasons. First of all, growth of individuals using AI in the last couple of years grew by 325%. Big time, if not even more by now. The market for AI will also grow by a huge number, $216 billion US. It's a number that's super hard to grasp for me, but is like quite a lot. And even more shocking is that 80% of AI-generated content is not checked. So that means people just push it out there and no one takes a second look. So there's so much trash out there. We have it as content, but we also have it as products. When you use chatbots, I think we talked about it earlier, that most of the chatbots do not do what they are supposed to do. Here are a few examples, less funny, but I just want to emphasize how important it is. We have on the top left an AI chatbot that tells a business to break the law. I guess not ideal. 260 chicken McNuggets were ordered at McDonald's, so I also don't think that's a correct order. And then also a lot of racial bias in AI, which is another problem because people are getting discriminated just based on their skin color or ethnicity or where they're from. And when we look at these, we are talking about companies like McDonald's. They're quite big. They have money, they have teams, they have tech experience, and they are seeing these fuck-ups. So it's even more important if you as an individual use AI, or if you're in a smaller team that maybe doesn't have these resources to really make sure you don't have these PR failures, because to get back from that, it's just really, really hard and costs you a lot of money that you can avoid for sure. Okay, so I think many people are already talking about how they evaluate their systems, how they make sure, or they tell you how they make sure the output is actually correct. And I just want to show you one example that I've seen at least 10 times in various companies or for clients that I worked with. And what we see there is that they are struggling with a lot of challenges, basically. So the first one is that it's really hard to reproduce an outcome of an AI, right? So all of you use ChatGPT. If you ask ChatGPT the same question 2 or 3 times, it will always generate a slightly different answer. And maybe the foundational idea is the same, but there are different nuances to it. So it's really hard to reproduce that. The second point is that it's not interpretable. So you don't really understand why it came to that conclusion, why it gave you that answer, and why you should accept it. So you just have to trust it in the end. Not ideal. And the last point is, another challenge of generative AI is that every one of us wants to automate their life. We want to have all these agents. We talked about systems earlier. No one wants to work anymore. But at the same time, no one really trusts AI. And that's obviously a conflict. How am I supposed to just let it run, answer my emails, do all the important stuff in my life, but in the end, I don't trust it. So we have a few conflicts here. And how people think they solve it is with something like that I call a manager dashboard, right? It's a nice dashboard within a company, a lot of colors, a lot of metrics, a lot of things that don't really tell you anything. So you maybe have metrics to measure how good your AI is that are called truthfulness, accuracy, conciseness. So very vague terms that are often also paired with numbers between 1 to 5. So you might get a score of accuracy that is, in this case, for example, a 3. But what does 3 tell you? How much better is a 3 than a 2 or a 4? Should I have a threshold of 2 or 3 or 4, whatever? It's very, very vague if we use metrics like that because they're arbitrary. We ignore domain experts as well often. So that means that we don't consult the people who are actually working on that topic. And a great example for chatbots, for example, is customer support. Often the chatbot is built without working with a customer support agent. And who else is supposed to give you an idea of if this chatbot is actually working than a customer support agent? Yeah, and I think the last point I already mentioned, too many metrics. You only need a yes/no answer to know if your answer should be accepted or not, if a chatbot is working or not. You don't need 10 metrics. You just need a yes or no. With that, we're coming to a 4-step solution. 4-step sounds snappy and more interesting. In general, it's more than 4 steps, but the high theory is that it's supposed to be 4 steps. And with the very first thing is you need to create a data set. And that data set should reflect the actual truth. Because if you build an application, you need to define first what is actually true, what are potential use cases, and what is the right answer. And coming back to that, the only way to do it is to work with domain experts. If you're building a chatbot for your customer support, the very first team member of that project should be someone from customer support who can tell you, this is good, this is bad, in this case, this should happen. Because if I, as a technical guy, would do that job, terrible idea, we would go bankrupt right away. So what should the data set contain? Like if we're talking about establishing this ground truth, what should it contain? It should contain examples for potential features your product has. So we'll go through an example after that slide, but let's think about a customer support chatbot for a travel agency. It's probably the most common example in the internet for it. We should have in that data set examples for all the features, but also for user personas. Maybe we have some users that are business users. Maybe we have some users who are users like I am one, just traveling for fun. And also for various scenarios. So there might be errors, there might be requests, there might be simple questions, there might be things that need to be escalated, whatever. And like the only thing that you should take away from this slide is consult a domain expert, and the more diverse your questions and your features and this data set is, the better your entire system will be in the end. This is what this data set could look like, right? So we start with a potential feature request. So a user might use your chatbot to cancel a flight booking for the next week. It's a very, very simple case. The persona could be a business client, but we could have the same case also for retail clients. So might be slightly different because in that case, the feature we want to test is that our AI agent system automatically cancels a flight that was flagged as, hey, I need to cancel it. And to make it a bit more spicy, we also add a new scenario, which basically just says, hey, this user, because it's a business client, has multiple flights next week, right? Because maybe they go to the city and go back. We're not really sure which flight needs to be canceled. And that's how you build this data set. And again, ask a domain expert. They can tell you 10, 15, 20, 50 of these cases right off the top of their head because that's their job. That's what they do. That's what, they can tell you the best, basically. Once you've established this data set, there's no right amount of entries you should have, right? The more, the better. If you have 100, great. If you start with 10, also better than 0, obviously. But over time, this should grow. Every time you come up with a new feature, add test cases to this data set. Think about it. And what we want to do next is we want to use a judge-like system, right? So ideally, our best case scenario is when we have an AI system, Ideally, it produces an output, and best case scenario would be that one of our domain experts would look at the answer and tell us, okay, this can go out to the customer or not. But in the end, this is not scalable, right? It's not an option that our domain expert revisits every single answer of an AI system, because then we can also just skip the AI system. So that's why we want to train an AI or refine an AI to act like a domain expert. So we basically want to replicate this behavior of a domain expert to basically be executed by an LLM. And for that, what we do is we use our AI system, we go back to this data set, we let it answer these different use cases. So our system is now being tested. We take the user input, we run it through our system, and we just look at the output and how it looks like. And with these outputs, we go back to our domain expert and ask the domain expert, hey, this is how our system basically answered these questions. What do you think about it? Like, do you think it makes sense? And if so, why? Do you think it was maybe wrong? And if so, also explain why. And that's what the output looks like then. So we have the user input again that we had earlier. The output is what our system generated as potential answer. We have the judgment by our domain expert. And as you can see here, we only have pass or fail. We're moving away from all these weird random metrics, and we just say our domain expert would accept it or would decline it. And also a little explanation, just so that we know why this answer is correct or why this answer is wrong. What do we do with it now? So we got feedback from our domain expert. We have an idea of how our system is working. And with that, we can build this LLM as a judge. So we use an LLM or an AI in between to judge our actual system. And we basically, like, what that looks like, it's just a very simple prompt. We pass like a prompt, hey, you are a judge, please judge our AI system, just to make sure that it works correctly. And for that, we use our previous examples. So we give it some actual examples and we say, hey, if this is a question, please basically look at the critique, look at the output, and you should judge it. Exactly same with the domain. This is what the output then looks like. So we start at the left again, and we have the AI output. That's basically what our system outputs, right? Then we have our AI judge now with a pass or fail judgment, right? It's very similar to what the domain expert did earlier, but now by our AI. And our AI also gives us an explanation why it decided so. So sounds quite good. The first three columns we give to our domain expert, so he or she does exactly the same. In this case, for example, you can see that the expert judge answered exactly the same way as the AI judge did. And that's a good thing, because that means this LLM that we trained in the middle, that acts as a judge, behaves exactly like our domain expert and makes the same decision. And that's why we have a positive agreement. So our domain expert, but also our AI, agree on the answer of our system. And that's great. Again, we do this for for the entire data set that we had earlier, to just see how often does our new AI judge actually agree with our expert. Because we want this rate to be as high as possible, because if it's at 100%, we've created an LLM as a judge that works as well as our domain expert. It's obviously very, very unrealistic to reach 100%, but the idea is just to come as close as possible with this LLM as a judge to a domain expert, because that way we can guarantee if we judge our system output, we're more or less evaluating it the same way a domain expert would do. How do we use it now? It sounds very abstract, and we're like, okay, like that was like very far from an actual use case. So first of all, you need to iterate. Like, that's a process. You have to do it 2-3 times. You have to look at errors. Where's maybe the judge and the domain expert? Where are they misaligned? Like, what are these cases? Improve it, improve it, improve it. And then over time, you see the agreement rate. So domain expert and AI judge improving. Ideally, you see them improving. That should be the goal. And then you can build an iterative system. And that's where, like, where we really add value to an AI system. Because before, we just maybe had a chatbot, it got answered a question, gave you an answer, we don't know, is it good, is it bad, no clue. But now, we can create something like that. So we start on the very left, we have a user, talks to our chatbot, right? The chatbot then generates an answer. This answer, before it is shown to the user, is being judged, right? And that's where our judge that we just trained, so like this fake domain expert, comes into play. And depending on the answer, we have different things we can do now, right? So let's say the answer was good. Okay, all cool. We do the yes path, and the answer can be returned to the user. Easy case. But what happens when the answer is not accepted by the judge? What happens when we identify, oh, this is actually not what we're expecting? What do we do then? One case is obviously we just say, hey, sorry, we cannot answer your question, but we all know how frustrated we would be if Booking.com wouldn't cancel our request, right? So it's not really an option. And what we can do is just loop back to the initial AI system. So we say, if the first answer doesn't pass, we just pass it through a second time, because LLMs give slightly, or AIs give slightly different answers every single time. We can give it another shot. We can say, hey, okay, just try again, like the judge said, doesn't work like that. We go back to the LLM, to the computer, basically, generate a new answer, let it be judged again, and then maybe it works, so we go the path above and send the output back. Or maybe we still say, actually, not really working, we don't see it. So what can we do then? We can again say, sorry, we cannot answer your request. Or maybe we do some web search, enrich the answer then, let it be judged again, and send it back to the user. What I want to say with this slide is only that because we have this judge now, we have the opportunity to say, we want to accept an answer of our AI system, or we want to decline it, based on the standards we've set earlier together with our domain expert. So we are now in control of our system. We can make sure that our answers are maybe not 100% accurate, but way closer to that than it was before. And by that, just creating iterative systems, which might be maybe a bit slower because there are more steps involved, but overall we can trust the system in just a little bit more. We know, okay, if we let it run overnight and people query it 2 a.m, we know it's not going to say anything harmful or even worse. Coming to the last part, so the common pitfalls. What should you avoid when you try replicating this? Because, I mean, we've all been there. We've read articles, we watched videos, and then in the end thought, okay, you know what, I'm a bit smarter than that person. Let me skip step 2 or let me skip step 3, just because it's a little bit faster. But in most cases, you'll get to a point where it won't work. So common pitfalls. Not providing critique is the first one. So critique was basically the part where we explain, we and our domain expert, we explain why a decision was made. Like why was an answer accepted? Why was an answer not accepted? And that just gives reasoning to these models. That explains basically the decision. And that's a core component of the LLM-as-a-judge, which we'll use. Second point, not enough context provided for the judge. With not enough context provided for the judge, that means the judge also relies on a prompt, right? And we need to be very accurate in prompting. We need to add some positive examples, but also some negative examples of what a good answer is, but also what a bad answer is and why it is like that. And again, add 2, 3 of those to add some context, because without, it runs a bit blindly. The third one is no iterative system. I think that was the point of the entire presentation, that a system that does not check itself, that does not iterate on its cases, on its answers, will never be a good system. Like, we might think that, but in most cases, this won't happen. So these iterations and like these checks, it has to perform itself, and we only saw a very simple version of it. They are really required and should never be skipped. And the last point comes back to the data set that we created in the beginning. This has to be diverse. If you, for example, imagine now we only have test cases for business clients in our data set, might work really well on business clients, but the retail clients or like travelers like I am, for example, like maybe we have different questions, maybe we have different problems, maybe we have different requirements, and they might not be met. So really take the time to go through the individual steps. There are a lot of resources on which explain this LLM-as-a-judge concept, and go through them one by one. It might take a little bit of time, but it's worth it, because after that, you can at least rely on whatever you've built and whatever you put out there. With that, thanks. If there are any questions, let me know.
Thank you, Agostino.
I guess my question would be around latency of a system like this. So the user gives a response, and how long are they willing to wait before going back? I guess speak to that, but then also what are some options for bailing out of the process if it is, timeouts or something along those lines?
Yeah, it's a good question. I'm also a very impatient chatbot user. That's why I would also quickly bail out. I think you can, obviously they're latent, you can run tests, right? You can test the system, see what's the maximum latency until when people would wait or basically bail. What I saw many times is that a chatbot just returns random answers. It's not necessarily related to the solution. It's more like, oh, that's a great question. Let me quickly check the docs. Okay, I just checked the docs. Let me cross-check it with something else, so that it looks like the human is getting answers, whereas this is not saying anything, but in the background, it's just running the same system. And obviously, there should be a threshold. It should not take 5 minutes to get that answer. There should be a hard stop at a certain time. That depends on the use case, obviously. But I think the trick that is most used is just pretending to explain the steps you're just performing, so that it looks like the user's getting answers while they're reading it. Maybe the real answer's generated already.
Yeah, cool.
But yeah, every step and every iteration obviously adds time. So it's always a trade-off between quality but also speed, where you have to find the right balance.
Thanks so much. A bit question about, I understood well how it works for business part, but maybe you have any ideas or examples also that works, how business will present it for their customers, this way of creating a trustment. We're talking a lot today about trustment, how they will present, because sounds well, everything well, but the main idea, common people have no idea about, they not go so deeply, and it's hard to them to understand this technology. I understand well, but the main idea, how company will present why this system should be trustable.
You mean why a customer should trust their system?
Yeah. No, I mean, for example, business start to implement this technology, and how they will present this for their customers.
It's the question if they need to, right? If the chatbot just works on its own, if every customer that uses the chatbot has a positive experience, then you don't need to prove it, right? I think the best way of proving that your system works is just make it good so people enjoy using it, instead of you need to tell them, hey, we do these 5 steps. It's actually really good. Please use it. I think the best experience is just making a good system and maybe taking a bit longer to develop it. And then, do it that way. I think, if I, for example, think about me as a customer, if I want to cancel my booking.com booking, I don't care if they tell me how they built their chatbot. I just want it to work. And if it works really well, it would be more likely that I would book through that platform again. And that's how I would see it. But it's personal. It's a personal point of view.
Thank you for presentation. You mentioned that AI critics step is important, but how are you using this information? Could you explain it a little bit?
Yeah, you use it in the prompt. So when you create this LLM as a judge, first of all, you give it a few examples, right? You say, hey, this is your task. And then you say, this is a good example because this is the critique from the domain expert. And then later on, when the AI outputs the critique, and it might be wrong for whatever reason, it explains you why it came to that conclusion. So let's say it would have, the flight cancellation case, it would have for whatever reason, outputted, like the LLM-as-a-judge would have outputted a fail and explained why it's a failed case, right? Maybe there was some wrong resources looked up or whatever. This gives you an idea where your actual AI system fails, right? This critique gives you insights into why something fails or why something passes. And with that, you can improve your actual system. Because if the LLM-as-a-judge, for example, tells you, hey, we didn't accept this answer because you looked at the wrong flight number or you looked at the wrong customer, then you know that your actual AI system is sometimes looking at wrong flights or at wrong customers. And with this critique, you get a bit more insights into why a certain decision was made.
So it's information for the human.
Exactly. For you as a developer, for example,
okay.
or like for the domain expert. You look at that and you say, okay, there are certain patterns in this critique, and maybe looking up the wrong flight number popped up 2-3 times. So something in our system must be wrong.
Okay.
And that's where it helps.
Thank you.